Dear students, we were discussing about database integrity, and we have discussed one of the protocol known as commit and rollback, and this is our second module on how to maintain database integrity, and today we will learn about locking of database. So first of all, let's have an example. There is a phenomenon known as incorrect summary problem. So suppose here is a account details of different people having different balances. So for example, this has 1000 as a balance. This has, for example, 2000, and this has 500. Our transaction is that we want to transfer 500 from account A into account C. Here is account C, and let's say this is account B. So this means that account C will become 1000 and account A will become 500. So as we discussed that this transaction takes multiple steps. So in first step, this 1000 will be read and put into the register. So for example, this is put over here into the register which is associated with the CPU. And suppose this has been decremented by 500 and stored over here back again as 500. So this is 500, but the 500 which have been decremented from account A has not been put into the account C. And at that time, if one transaction tries to identify the summary of the amount we are holding into the bank accounts, so that would be wrong. So for example, previously it had 1000 plus 2000 plus 500, so it is 3500. However, now it would be this 500 and this 500, this would be 1000, and this 2000 would be 3000. So it should be 3500, but actually the summary which we are getting is 3000 because those 500 which were deducted from account A has not been put into the account C, and in the meanwhile, in the middle of this transferring fund from one account to another, that transaction has asked to identify the overall summary of the account. So there is another problem related to locking. For example, two transactions want to deduct from the same account. So let's say here we have again account A and this has, for example, 1000, and there are two transactions. One transaction want to subtract 300 from this account, and second transaction want to deduct 200 from the same account. So suppose first transaction read this 1000 and transaction 2 should not be allowed until transaction 1 is able to deduct 300 from this 1000 and making it as 700, and then that 700 should be read by transaction 2. So however, in this problem what happens that transaction A reads this balance as 1000 and transaction 2 reads this balance as 1000 again, the same, because transaction 1 has not updated and that updated value has not been used by the transaction 2. So what will happen? So this 1000 by executing instruction 1 will become 700, and that 700 will be saved over here. So it will become 700. However, the instruction 2 has read 1000 and that 1000 will be subtracted by 200, and again it will be saved on the same location, and it will become now 800. So what we are saying, that two transactions want to deduct from the same account. If one reads the account current balance at the point when the other has just read the balance but has not yet updated the new balance, then both transactions will base their deduction on the same initial balance, which was 1000 in this example. So what is the solution? How we can solve such a problem? One solution is, of course, that DBMS could force such transactions to execute entirely. So it can say that transaction A should complete its turn until that no other instruction can be executed onto CPU. So this would be problematic because this is a multi-sharing, multi-programming platform that multiple programs and multiple processes, threads are being executed by the CPU at one time. And how can we say that no one is allowed to use the CPU until we are done, or this transaction is done, or the instruction 1 is done in the last slide? So, and you know that the instructions which are reading from memory and writing on the memory takes a lot of time. So the next solution is that you can lock that particular location item in the memory. So for example, that 1000 when read by instruction A, that would be locked. So all instructions can be executed on CPU but are not able to update or read from that particular location until that lock is removed after completing the instruction A of detecting that balance, and then the lock is open, and then that can be used, that value can be used by other instructions. So there are two types of locks. One is shared locks and another is exclusive lock. What is shared lock? Shared lock is the transaction is not going to change the data, it is only going to read. Then one can use shared lock. What does it mean? This means other transaction can also view the records but cannot update the value. So the instruction A, or first instruction, is just wanting to have that account information for summary purpose or for viewing purpose, and that instruction is not going to update that account. So others are also allowed to see that what is available in that account, but are not allowed to update, because if they update, then the first instruction might have the different balance which is actually stored and which is being read by that particular transaction. The next kind of lock is exclusive lock. In this lock, if the transaction is going to alter the item, so this means that 1000 will be decremented or incremented, in that situation no one is even allowed to see that. It must have exclusive access, meaning that it must be the only transaction with access to that data, and others will not even be able to view, because if they are going to view, so first time it was 1000 and that instruction has subtracted or deducted 500 from those 1000, so the new value will be 500, but other instructions are viewing 1000, and they will not be getting the chance to know that this amount has been deducted from that account. So this means we can implement the exclusive lock in this situation. So today we have learned about how database integrity can be maintained using locking, and we have discussed incorrect summary problem and lost update problem, and we have discussed there are two types of locks: shared locks and exclusive locks.